Good morning. So we have covered the detailed classification of Rapier shuttleless loom. We have seen the drives, various types of drives. We have seen conventional drive, modern drives. We have seen also we have seen the introduction of shuttleless loom. So next we'll see the features of shuttleless loom. What the features the shuttleless loom is having. What the elements of shuttleless loom we will see. So we'll start with the loom G6200 Suzer Ruti Rapier loom, and we'll cover one by one feature of this loom. So here we can see the complete loom is shown here, how the drive is going and how the elements are there. So complete thing we can see here. So we'll start from front sides here. This is what take up motor. So take up motor drive is going to this worm and worm wheel, and then it is going to the change wheels, and here it is going to the what take up roller. So from take up motor, worm and worm wheel, and change pinion to the what take up roller, and from take up roller the drive is going to the what cloth roller. Take up roller, it is going to the what cloth roller. So take up pulls the fabric from the fell of the fell of the cloth region, and it winds on the what cloth roller. So a separate motor is attached here. So in conventional loom we have seen what 7 will take up mechanism, 5 will take up mechanism, but here it is not like that. Next we can see here let off motors here. Here is the let off motor. Again from the let off motor, worm and worm wheel, gearbox is there, from gearbox pinion is there, and this is what big wheel attached to the beam pipe, and here is the what let off motor. So this is what let off motor and take off motor. So let off and take off, here separate motors are there, and these are not negative type, these are what 100% positively driven and having its own control. So separate motors, inverter type motors we can see. So this is what take up unit, and this is what let off unit we can see here. After that we can see here main motor we can see here. From main motor, here drive has gone to here clutch, we can see here R clutch. So here change of pulley we can do. So clutch is there, clutch engage and disengage is there here. When any war stop motion is there, war breakage is there, here clutch disengages. Motor runs, main shaft doesn't rotates because clutch has disengaged. So motor is rotating, but clutch is disengaged. So we know the function of the clutch. Then this is what main motor and main shaft. From the main shaft, so here see here this is what main shaft, from here the drive goes, this is what main shaft. From the main shaft the drive goes to the left side of the machine. From left side of machine it goes to the what, it may be dobby, here the dobby is there, or jacquard is there, F is shown in the figure. Again from this the drive goes to the weft selector device. So we can see here M is the weft selector, 1 2 3 4 5 color is there, so 5 wefts will be there. Then we can see here left hand flywheel is there, the drive goes to the left hand flywheel. Here also right hand flywheel will be there, the main shaft drive will be going to the right hand. Here the only left hand N is, we can see the flywheel. So Rapier drive is there, from main shaft the drive goes to the Rapier drive. So from in the left side we can see 3 drives has gone. One is the what Dobby or Jacquard, then left Rapier drive, then weft selector device. So next again from main shaft the drive has gone to this here. Behind the main shaft we are having the Q motor, this is what peak finding motor or slow speed motor. From here the drive to the gear, it has gone to again main shaft. So drive has gone like this, not from the main shaft, peak finding motor from here to here. So total we have seen 4 motors here. One, let-off motor, take-off motor, peak finding motor, clock take-off. So main motor. So here are the what drives we can see. So why this peak finding motor is required here? Whenever the clutch gets disengaged, so main shaft gets disengaged. Main shaft doesn't rotate, and we have to drive the machine one peak ahead or one peak backward. That is done by this small motor Q, peak finding motor, forward and backward of the what machine. So this is what slow speed motor. Again here W we can see the signal device. If any wet breakage is there, warp breakage is there, depending upon the signal we can see what the problem is there. E is here electronic warp stop motion. In detail we'll be studying that. Here again B and G is there, buttons are there, controlling buttons, inching buttons. This is what Y, stop motion. This is what control panel. In the control panel we can insert the data. Here again we can see cone, tensioner, accumulator, weft brake, weft sensing device if weft breakages. So this is our overall subunits. So one by one subunit will be covered. So we'll do again revise. So what the things we have seen. So we have seen operator and display terminal A. So this is what complete operator and display terminal A. Then B, operating keyboard. So this is what keyboard is there to operate the machine. C, warp let off. So here the warp let off is there. D, warp tensioner is there. So we can see here backrest is there. D, warp tensioner. Then E is the warp stop motion. Here the complete E is warp stop motion. F is the shading device, we can see F is the shading device. Then G is the slave drive and read. So we can see in the figure G. So here the G is there. Here is the slave drive and read. Then H is the cloth take up. Cloth take up. I is the what? Cloth wind up. Then H is cloth take up motor. Then J is weft feeder. So we can see here weft feeder is there. J, accumulator, complete accumulator is here. K is weft brake. K is weft brake here. Then L is weft monitoring. So weft monitoring is there. L, that is what works on conductive or optical based principle. And the weft is not there, the machine stops. Then M is peak sequence control. Here which peak should be inserted or which color of weft should be inserted, it is controlled here, and that finger goes down. Then N is tape wheel and rapier tape. So N is, here we can see N, rapier wheel and tape it is. O is weft and lifter. So we can see here O, weft and lifter is there. Then P is the main motor. Here we can see main motor is there. Q is the slow speed motor, creep speed motor. R is the clutch and brake. This is what clutch and brake device. Then U is peak finding clutch. Here we can see here peak finder clutch is there. Here also clutch is there. When main motor clutch disengage, this clutch get engaged. So reverse functioning of this clutch is there. Then W is signal column. This is what signal column is there. Y is emergency stop motion. So these are all the elements of the Rapier weaving machine, and these things one by one every section will be covering in the next coming slide. So this is what overview of elements of the or features present on the Rapier weaving machine. So see the figure one more time. If any question is there, you can send in the chat. So this is what driving diagram. So in the last figure we have seen this driving diagram. Again one more time we will see how it going. So here is what main motor. Again from here the clutch is there. Here drive goes to the main shaft. This is what main shaft will. From main shaft the drive is going to the sleigh. Two conjugate cams are there, one for forward movement and other for backward movement. Like this the drive is going from the sleigh. Again main shaft goes this side, other side of the machine. Here the drive goes to the shading mechanism. Here we can see from here, from main shaft the drive goes to auxiliary shaft. This is what auxiliary shaft. From here the drive goes to the what other side, 13 we can see other side. From main shaft, auxiliary shaft, then it comes to the other side of the machine, and then shading mechanism. Then we can see here web selector device, then left hand Rapier drive. Here also right hand Rapier drive will be there. So this is what main shaft drive. Then again we can see here let off motor. From let off motor change places worm and worm wheel, and this is what take up roller is there. This we can see here. And again here is what let off motor. The let off motor drive is here. Then from here is what slow speed motor. Slow speed motor shaft is there, clutch and slow speed motor. The drive is going to the main shaft. So this motor gets on, this shaft gets moves when this main shaft is off or clutch gets disengages. Here slow speed motor clutch gets engages. So this is what drive diagram. So here we can see drive to the salvage motion, left hand and right hand salvage. Here the drive is going here. So see the drive carefully. So total 4 motors are there, 1, 2, 3 and 4. So see the drive one more time. So here shading drive, from 2 the drive goes to the shading mechanism. So in the drive what are the things we are seeing? We'll revise. One is power warp let off. So this is what power warp let off. Second shading mechanism drive. Here is what shading mechanism drive. Third is cloth transport gear. Here we can see here cloth transport gear. Fourth take up roller drive. So we can see here take up roller drive. Then fifth cloth take up drive. So here we can see from motor 5 the cloth take up drive goes here. Sixth cloth wind up drive. So here the drive comes from here main shaft. Again here clutch is there, and sixth is cloth take up drive here. Then seventh is sleigh drive. So we can see here sleigh drive is there. Here we can see seventh. This is what sleigh drive from the main shaft. Eighth hand wheel is there. Here is the hand wheel to move the machine in slow motion forward and backward when clutch is disengaged. Ninth is tape drive wheel. Ninth is tape drive wheel. We can see here tape drive wheel. From this is what hand wheel, tape drive wheel to the drive is going to the tape. By the hand we can rotate front side and back side. 11th is tape wheel, so we can see tape wheel. Here also the tape wheel on the right hand side will be present. 12 full cross lino drive, we can see here 12 full cross lino drive. Then 13th is electronic peak sequence control, so we can see here electronic peak control is there at the 13. Then 14 is main drive and brake. Sorry, 14, this is what main drive and clutch and brake here. Then 15 slow speed gear motor, 15th is here. And 16th main driving shaft. So 16 is here main driving shaft. This is what main driving shaft. Then 17 rear driving shaft. So we can see here this is what rear driving shaft 17. From here the drive has gone to rear shaft also. On the rear shaft we are having lino devices. So from main shaft the drive has gone to sleigh. Again the drive has gone to auxiliary shaft to the opposite side, and again to the Rapier drive or hand wheel. So Rapier drive right hand side, and again back side it has gone it is. So how many shafts are present here? This is what rear driving shaft, main shaft, sleigh shaft, then auxiliary shaft. Like this the shafts are there. So here main drive of Dobby we have seen, sleigh drive we have seen, tape drive we have seen, cloth winding we have seen, and electronic sequence control. So in the drive we have completed all these things. The next year we will see the features of the machine. So first we'll concentrate on warp let-off. So we can see in the figure how the warp let-off is there. The let-off is present at the back side of the machine. So this is what power let-off covers a peak count range from 6 to 200 peaks per centimeter. So let-off can be used from the range 6 to 200 peaks per centimeter. So from 6 peaks per centimeter to 200 peaks per centimeter, this let-off can be used. So it can be varied as per the peaks per centimeter. It can be programmed for different wave densities. So in the control panel we can add the PPI, and same PPI signal will go to the let-off motor, and let-off motor will accordingly it will be releasing what warp, and accordingly the take-up of the fabric will be taken. So signal goes to both let-off and take-off when we insert the peak PPI in the control panel. So this is what the unique feature of this let-off. Suppose I want to run 100 peaks per inch. So 100 peaks per inch from the control panel, the signal goes to this let-off motor and take-off motor, and accordingly the fabric will be pulled and the warp will be released for the per inch to adjust the 100 peaks. So this is what the main peculiarity of this warp let-off. The warp tension is kept constant to a given set point. So we can set the warp tension constant from start of machine to end of the beam, start of beam to end of the beam. The configuration of warp let-off gear 3 depends upon, so whatever the configuration or change places are there, this and this gear, when we have to change here, depends on the required number of peaks per centimeter in the fabric, warp beam flange diameter. So this is what warp beam flange diameter or content of warp diameter, and the machine speed. So on three things this combination of this gear depends. The link with the warp let-off gear is disconnected. So see here is having the clamp. So how to release the complete beam from this let-off device here? When we release the clamp, both sides the clamps will be present, left hand and right hand. When we remove the clamp, automatically the beam comes outside on the trolley, and easy handling is there. So this is what the warp let-off. The feature is what unique feature, we can insert the peaks per inch or peaks per centimeter in the control panel, and it automatically adjusts or release the warp according to the peaks per centimeter or peaks per inch, and accordingly the cloth will be pulled by the take-up roller. So next we can see here, this is what warp tensioner. So what is the feature of warp tensioners here? What we are doing here? So we can see here, suppose a 5 kilonewton warp tension is there at the backrest. From start of the beam to the end of the beam, we are maintaining the constant warp tension. So how we are keeping that? We'll see that. Next here, one thing is to keep the tension same at the start of the beam and at the end of the beam. As the beam exhaust, the tension remains same when the beam is full and when beam is getting exhausting. This is the thing. And next thing see here, when the shade is opening and when the shade is closing, again the tension in the warp is what? Similar. So at the two times we are maintaining warp tension constant. So 5 kilonewton warp tension, it is presetted when we are starting any new quality. So at the start of the machine, at the start of the new quality, we are setting this tension, and whatever the tension is set, this remains throughout the change of the beam. This tension remains the same. So how we are doing that? See here. So first we will see the parts in the warp tensioner. So this is what backrest, complete backrest of the machine we can see here. So one is what? Backrest roller, or these two are called as whip roller. So here two is what? Whip roller. Small two rollers will be there, here arrow shown. This is what? Whip roller. Then second we can see here vertical adjustment position. We can screw, we can loose the screw and we can lift the backrest up and down from the both the sides, left hand and right hand, and here the scale is present. So vertical lifting of the backrest can be done depending upon the scale. On each side the scale will be seeing or looking to the scale, we can adjust the backrest vertical position. And horizontal position of the scale, position of the backrest is adjusted by this scale. So vertical scale is there, horizontal scale is there on the both the side of the machine. So preset level of tension, preset tension we can adjust by this, by adjusting backrest vertical and horizontal. And when it's 5 kilonewton comes, up till the 5 kilonewton not coming, we'll adjust this setting. Next setting, see here, here we are having the torsion bar inside this, not the projectile torsion bar, but here 4 number we can see a tensioning bar is there. So we have to adjust this tension. So we get scale is shown here. So when we move this, here the moving point is there, this torsion bar moves clockwise and anti-clockwise. So we are moving such that 5 kilonewton warp tension comes on the backrest. So this 5 kilonewton tension where we can see this digitally. Here we can see it digitally, or on the control panel we can see. So we are adjusting the tension of the bar, flexible bar, unless and until 5 kilonewton doesn't comes. So when 5 kilonewton comes, we are fixing this nut, and first we are losing this nut by this arrow or by this nut, check nut. We are adjusting what 5 kilonewton. After it comes, we tight these lock nuts. So these are the whip roller setting. So one is vertical or horizontal setting. Next is torsion bar setting, or a backrest spring setting it is called as. Here the spring is not there, here the bar is there. So this is on one side of the machine. On the next side we can see here, like this device is there. This is called pendulum is there here, pendulum. And 6 is here position sensor is there. And 5 is here safeguard switch. So here is the pendulum. When 5 kilonewton comes here, from the positioner sensor and that pendulum, certain distance is fixed. Okay, so suppose 1 centimeter distance is fixed when 5 kilonewton tension is there. When this pendulum moves away from the sensor, the change in the signal is given to the warp let-off motor, and according to the let-off motor speed increases or reduces to keep the distance 1 centimeter same here. Suppose the pendulum is gone forward or forward, and 1 centimeter distance is not there, it tightens the warp and brings the pendulum to the center again. Suppose the pendulum has gone left side, means tight warp is there, you have to release more, means the tension has gone to 7 Newton, it should be 5 Newton. So pendulum position is this. So you have to release the warp more so that the pendulum will be loose and it comes to this position again, 1 centimeter distance kept constant. So whenever the 5 kilonewton is there, the 1 centimeter distance is there. When this pendulum diverts, the distance changes and change distance signal is gone to the let-off motor, and let-off adjusts the speed, increases or decreases to maintain this position same and tension same. So like this way we maintain constant tension in the warp from start of the beam to the end of the beam. Suppose the tension is more in the warp, the pendulum will what happen, hits the proximity switch, and what happens, the machine stops. So once again I will discuss here. So 5 kilonewton tension is there, pendulum will be at the center. When the tension increases, the pendulum diverts to the right side and 1 centimeter distance is not maintained. Then tension has increased, means what will happen, it has gone to 7 kilonewton, you have to bring it to 5 kilonewton. So what happens, the warp is tight, so you have to release more warp. After releasing the warp, again pendulum comes to the center and maintains 5 kilonewton. Suppose 3 kilonewton tension is there, your pendulum will be loose and it goes shifted to left side. This arm will go to left side and your warp is loose, 3 kilonewton, and distance has changed. So what happens now, you have to reduce the speed of the motor so that again warp becomes tight and the pendulum comes to the center. So like this we are adjusting or keeping the tension of the warp same from start of the beam to the end of the beam by this proximity sensor, and this proximity sensor signal goes to the let-off motor. So basically we set the preset tension level 5 kilonewton by vertical horizontal position and torsion rod, and then we try to keep this 5 kilonewton same. So this is what the feature of any let-off motion. So see the figure for 2 minutes, and if any doubt is there you can ask me. So this is what warp stop motion. So why the warp stop motion is required here, whenever the warp breaks, the stopping of the machine should be there. When the machine doesn't stops, the missing end fault will come in the fabric. Complete that warp will be missing throughout the length unless and until the viewer sees the machine. So warp stop motion is very important. If this warp missing end is coming, your fabric will not be passed in 4-point checking system. So see here the features. So first we will see the parts. This is what drop wire, and these are drop wire rails. So how many rails are there here? 1 2 3 4 5 6. So only one rail is shown here. So this is what second is a rail, and this is what drop wire. So drop wire depends upon the what yarn count. If coarser yarn is there, the weight of this drop wire in gram will be more. If finer warp is there, weight of drop wire will be less. So selection of drop wire is very important here. Then see here, there are two types of drop wires, open and closed. So this is what closed drop wire. Open means when the closed drop wire is there, we have to put these drop pins or drop wire at the time of drawing denting operation. And whenever the open type of drop wire is there, we can put on the machine after tying the beam. If close is there, you have to put this drop pins at the time of drawing and denting only. And these are what open type of drop pins. We are put these drop pins from the topward side. We can see here like this. So this is what very important thing here. Drop pins 1 2 3 4 5 6 lanes are there. Suppose 3000 ends are there. One rail will contain 500 ends. 500 ends, 500 ends, 500 ends, 500 ends. Total 3000 ends in the warp. So the configuration of warp stop motion depends upon warp density, that is EPA of the fabric. Second, warp yarn, what type of warp yarn you are using. Third, yarn count. To count of the yarn, it may be coarser or finer. So mostly the main things are here is what warp density and yarn count. So proper selection of drop wire depends upon that. So see here how it works. Whenever any warp breaks, the third point in the figure we are seeing here, warp breaks. Whenever the warp breaks, the drop pin falls here down. When drop pin falls here, it falls on the what rail, and electronic circuit gate closed, and the viewing machine stops. Whenever the electronic circuit gate closed, the signal goes to the main motor, and main motor doesn't stop, but clutch get disengaged. Main motor gets, it runs 24 hours. It doesn't stops. Only the clutch we are disengaging. Clutch disengage means what? The drive from main motor to the main shaft has disengaged and the machine stops. So main motor will run. So these things happens here. If the warp stop motion is not working properly, the missing end fault will come in the fabric. So selection of drop pin is very important here, and again open type of drop pin or closed type of drop pin. These things are very important here. So next here we can have high speed shading connection to the looms, Rapier looms. So here one we can see the shaft from the bottom side, the jacks are there. So 20 shield shaft will be there, 20 jacks will be there, like 1 2 3 4 jacks, and these are the levers 1 to 20, and this will be jack runners to adjust the height of the shade here, and these are shading levers here. So discs are there. This is what rotary electronic Dobby. So 20 rotary Dobby disc will be there, 1 2 3 like this, 20 disc will be there. So this is what high speed shading rotary Dobby. So now the concept is electronic rotary Dobby, not the tappet shading or positive cam shading. Nowadays we are having what, this high speed shading mechanism, so that we can connect here. The drive for this Dobby shaft comes from the main shaft. So this is what Dobby shading. So we can use the Dobby shading, electronic Dobby of, that is what, Stobly rotary Dobby. We can use film textile rotary Dobby here. So see the connections, how it is, how the connection is there for the heel frame. The heel frame are moving in the side bracket. So left hand side bracket we can see, right hand side bracket. This Dobby shading suitable for high speed shading. So here high speed jacquard shading we can see. This is not mechanical jacquard, this is what electronic jacquard. Here is what the lifting hooks are there. 1 and 2. This is what 1 and 2 hooks are there. These are the what knives, upward knife, downward knife, upward knife, downward knife. This is what pulley. These are the hooks. We can see this is what magnet. This is what magnetic element. So electromagnetic shading device is there. So this is what high speed shading. This is what lifting knives. Then from the main shaft again the drive has come by the connecting rod and it has gone to the knives. So only knife drive is what here mechanical. Rest all the things is what electronical. So this is what electronic shading. So here the shading bonus company is there, gives the electronic shading devices to the bottom of the machine. This is what high speed shading. So this is what next is what beat up or slay motion. So we'll see how this feature is working here as compared to the conventional slay motion. In the conventional the beat up is by the main shaft crank and crank arm. So here it is not crank and crank arm. So one difference we can see here in the shuttleless loom, there is a dual for the sleigh, and in the conventional loom the dual for the sleigh is not there. Dual means here dual in the shading we have seen, but here dual in the sleigh is there. So what is meant by that dual in the sleigh? Means what? When the sleigh goes at the back side, back center, the sleigh stops completely at zero velocity, and then the weft will be inserted. And when the completely the weft is inserted, then the sleigh comes for the forward beat up. So sleigh is rest at the backwardmost position for near about 90 degree, and this is called as what dual, and this is not there in the conventional loom. Conventional loom we are having eccentricity of the sleigh. Eccentricity of the sleigh means when the sleigh comes for the forward movement, it comes fast for the beater, and when sleigh goes at the backward movement, it goes slowly. Very slow it goes, and in that slow motion we have to insert the shuttle. But here the sleigh is not stopping here for 90 degrees and the dual is not there. So this brings the eccentricity in the loom, difference in the speed of the loom, and this creates a load on the machine part. To control this sleigh is very difficult, and the load on the machine drive is coming, and breakage of machine part may be there if eccentricity ratio touches to the 1. So always see that eccentricity in the conventional loom should not be up to 1, it should be very less amount, 0.50, 0.60. So this eccentricity is not there in the sleigh motion. In the shuttleless loom we are having dual. So this is what the basic difference we can see here. So first see the parts here. A means what? Reed coming for the beat up. B means what? Rearmost position of the sleigh. Here 1 is the sleigh shaft. 1 is the sleigh shaft. Then 3 is the sleigh. Second is what here? Reed. See here, reed. Okay. So here we can see this is what main shaft drive. Main shaft drive. This is what main shaft drive. On main shaft, 2 cams are sitting here. 5 numbers here. 2 conjugate cams. They are called as what? Complementary cams, match cams. On the both the side of the machine, these match cams are present for the heavy beater. So 2 pairs on this and 2 pairs on this side, left side. So 2 match cams giving drive to this sleigh shaft. So we can see a sleigh shaft. On the 2 match cam, bowls are there. So we can see here one bowl here, one bowl on the opposite side touching the other cam. 2 cam means what? Facing opposite side, like tappet shading facing opposite side. The 2 cams are there, one for forward movement of the shaft and one for backward movement of the shaft. So forward and movement of the sleigh shaft means what? The reed will come one time forward and reed will go one time backward. So this is by the what? By the match cam sitting, 2 match cam sitting on the what? Main shaft and giving drive to the saddle by the bowls. So one bowl touching to one cam and other bowl touching to the what? Other cam. So this sleigh shaft, and this is what main shaft. So one time sleigh shaft will move forward and other time it will go backward. So this forward and backward movement, we are achieving this motion in 360 degree of the loom rotation, 0 to 360 degree. So how it is possible, we'll see that. So see the figure carefully. So see here how it is possible here. In this figure it is explained here. So 0 position, 90 degree position, 180 degree, 270, 360. So 0 to 360, what is happening here? A is what? Forward most position of the reed, A. So from 0 to here, from 0 to 110 degree, the reed moves back. So B is what? Rearmost position of the reed, B. So from A to B means what? From A 0 to 100 degree the sleigh goes back. So A is forwardmost position, B is backwardmost position of the sleigh. A is fell of the cloth here. So 0 to 110 degree the sleigh goes back. So we can see 110 here. The 110 to 240 degree. From 110 to 240 degree D is there. The dual in the sleigh. The sleigh is rest position at the backwardmost position for the degrees 110 to 240 degree. It is completely rest. From 240 to 360 the sleigh will be moving what? Forwardmost position. So this is what? Forwardmost position. So this is one cycle, 0 to 360. Again next cycle next will start. So see, we can see here sleigh stroke, sleigh backwardmost position to forwardmost position. So unique feature of this match cam system, match cam beat up system is what? D is there here, dual in the sleigh. So dual in the sleigh we can bring it by selecting the what type of the cams. Two match cams. So match cam is having that dual of 120 degree. So when we change the cams, the D part or dual part can be changed. But when while purchasing the machine, the D part is fixed and cams of that dual is fixed. So when width of the fabric changes, so see here, when the width of the fabric changes, the dual has to be changed. More width of the fabric, more dual should be there. The match cam of that dual degree we have to select here. More the width, more the time is required to go the web from one side to other side. Obviously more dual will be required here. So this is what the dual, this is what the sleigh stroke, this is what A is forwardmost position, B is what? Backwardmost position. So I think all the features whatever the covered we are covered in today's lecture is clear. Once again see the second figure given here, how it works and how it is different from the what conventional beat up crank and crank arm mechanism. See the figure for a minute. So next features will be covering in the next coming lectures. So we'll stop here.